Today we're going to talk about conditional probability. The probability that one thing happens given that another happens. So conditional probability of event B in relation to event A. So you're given two different events. It's a probability that event B will occur given the knowledge that event A has already occurred. So you need to have one event that's already given to you to have it be conditional. So how this is read is the probability of B given A. So the probability of event B happening given we already know event A happened. Now how we're going to find that is we're going to take the probability of both A and B happening and divide it out the probability of A happening. And that'll give us our conditional probability. Alright, so I don't know, is this written down for you or do you just write that down? You get it write it down? Okay, do we all write it down? Okay, so probability of B given A equals probability of A and B both happening divided by the probability of A happening. So example 1. The probability of drawing 2 kings from a deck of cards. Is this going to be a conditional probability problem? Is there any given in this problem? No, this one's not conditional. I don't know why we haven't put in the notes, but we do. So we're still going to do it. What's the probability I pick a king the first time? 4 out of 52.
113.
Which is also 113. And picking the other king would be 3 out of 51. Okay? So this is a non-conditional problem. There's nothing given, just a normal probability problem. What's the probability? Using your calculators, because I know you all have them out. 1 out of 221 when reduced, which comes out to about what percent? I don't know. Approximately 0.5%. Right, 0.45 round up. So if you want to write it as a percentage, you can write it as a decimal, or write it as a percentage or a fraction reduced. Right, so that's a non-conditional problem. That's one we've done before. We've done stuff like that, right?
Wait, did you just say 1 divided by 221?
Yes, because it reduces to this cube.
It's got 2 zeros.
It's not 2 zeros, that's 1%.
No, it's less than 1%.
It's less than 1%.
That is less than
That's less than 1%.
No.
Your decimal comes out to 0.005.
Yeah, and that's...
So times it by 100.
When you put
Okay.
a percent on it.
Multiply that
Times it
by
by 100, it'll give you a percent.
Not average.
I'm being sassy. You guys are coming at me.
There's no need to yell. Hey, there's no need
I'm trying to explain it to him. He goes, "No, you're wrong. No, you're wrong."
Because we're not.
Just an outrageous showing.
Why would that...
I just,
Yeah, take a breath. Do you need to go in the hall for a second?
yeah, I might need to take a laugh. I might need to laugh. All right.
This is on video, by the way.
I know it's on video. All right. Hey guys, let's do a conditional probability problem now. So 70% of your friends like chocolate. 35% of your friends like chocolate and like strawberry. So what percent of them who like chocolate also like strawberry? So our given here is that they like chocolate, right? That's what they're saying. We know they like chocolate. What's the probability they also like strawberry? So the probability of strawberry given that they like chocolate. That's our problem here. So probability they like strawberry given that they like chocolate. Well, remember we want the probability of both things happening over the probability of the first happening. Well, what's the probability they like strawberry and chocolate?
35.
35%. I'm going to write it as 0.35. I don't know, you could leave it as 35, it doesn't make a difference, but I like to use decimals. Just weird OCD thing that I do. Divided by, what's the probability they like chocolate? 70%.
0.7.
So I'm going to use 0.7. Like I said, if you want to use 35 and 70, it'll give you the exact same answer. Okay? So 0.35 over 0.7. What does that give us? Is it
50%.
50%, right? Or 1/2. I like to use percentages. Same thing as 1/2. Right? If you want to write it as a fraction, you can. Alright, so probably they like strawberry given they like chocolate is 1/2 of them. Does that make sense?
Yeah.
Yes? No?
Yeah.
Okay. Try another one. In New England, 84% of the houses have a garage. 65% of the houses have a garage and a backyard. So we have both. We have a garage. What is the probability that a house has a backyard given that it has a garage? So we want a backyard given it has a garage. So the probability of both was 65 here. I'll do one as a whole number. 65 over the probability of a garage, which is 84. Because the probability of both over the probability of your given. What do you get? Approximately 77%.
Yo.
Yeah.
What if we went up to a decimal? Let's change things up a little bit.
77.4%.
No,
What?
it's 76.
Yo, punch them.
No, it would not be 76.4. It would be 77.4.
77.4.
77.38.
We are really struggling with calculators today.
Wherever you go, 4.9.
What?
That's a percent. That's a percent written. Yeah.
Yes.
That's what I'm saying. What? It looks like.
Hey guys, do you understand what we're doing here? Like what we're actually taking the probability of?
Bunch of numbers.
Yes? No?
Refresh my memory.
You can't say yes and then shake your head no.
I have no idea. Yes.
You have no idea.
Even if it's down.
That's rude to assume for Dom.
What do you think?
So guys, we're looking at the probability. Whoa.
It's been a long
Do you
day.
feel dizzy?
A little bit, this is helping.
I knew it.
We got deadlines this week.
Alright, going on. So we can't handle, alright. In a school, probability that a student takes environmental science and geography is 0.25. The probability that they take environmental science is 0.72. What is the probability that a student takes geography given they take environmental science? So we're looking at the probability of geography given that they already take science. Right? Well, what's the probability that they take both? 0.25, that they take both environmental science and geography. What's the probability they take environmental science? 0.72. So what's the probability that they take environmental science given, that they take geography given they already took science?
34.7%.
What a bigger number on bottom?
Always, Pat. Always.
Well, I wasn't asking.
Otherwise,
Normally
we
the bigger number will be on bottom, yes.
Normally it's
Normally.
always.
Very rarely.
There's no more. You can't get more.
Alright, any questions so far? Alright, let's look at some graphs a little bit. So we're given a table here. The question, do you drink chocolate milk regularly, was asked of 100 people. Regularly was defined as 3 times or more per week. The result of the survey is shown on the table. So they split up into boys and girls, they split up into yes and no's. Alright, does everyone know how to read a table like this?
Mm-hmm.
Right, so this is like 28 boys said yes, 12 girls said yes, 27 boys said no, 33 girls said no, and then there's totals, so the whole thing. So we want to know, what is the probability of a randomly selected individual being a boy who drinks chocolate milk?
55%.
Is that, what?
Did you say milk?
Chocolate milk.
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 Mole.
It's milk. It's milk.
Put it off task, Mr. D.
Yeah,
Come on.
see, Noel's just trying to get us
Roll
off
it
task
back.
so we don't
I'm
get work
not
time.
hurt
Where's
it
the A?
here.
Where's the A?
Hey! What?
It's an E.
No. Okay, in Spanish, if you say A,
Patty?
it means E. If you say
Alright.
B, it means A.
Hey!
Sorry, continue.
Guys, is this a conditional probability problem?
No.
No, right? There's no given. We're not asking on one thing based on another. We just want to know what's the probability that it's a boy who drinks chocolate milk.
Milk.
What?
51%.
0%.
Am I right?
51%. What the
Where
heck?
do you get 51%?
How do you get 51?
Wait,
Shh, quiet. So we want the hey guys, We want the probability of it being a boy, and they said yes. Well, how many boys said yes? 28. Out of how many total people who were surveyed?
100.
100. So it should be
I did it out of the total boys.
So how do you get 50?
28 or
Yeah,
55.
that's right. I did it
Relax.
that way.
Deep breaths. Relax.
How do you get 51?
Wasn't someone educated?
Hey, Quentin, don't worry about it. We're not even worrying about it.
Because I didn't
But
do
it's
myself.
55.
Quentin, 28 divided by 55. Do it in your calculator.
No, not that. I thought she took 55 divided
No.
by 100.
That's not what I did.
What is the probability of a randomly selected individual being a boy? Once again, is this conditional? Is there any given here?
No.
No. We just want the probability of it being a boy. So probability of a boy,
55 by 100.
55 divided by 100. Which is 55%. I mean, I'm sure you can reduce it down. Right, was that 26 out of 50, 13 out of 25?
Who you asking?
If you understand. Anyone who get it?
God of luck.
Oh, sorry, I was wrong anyway. I did it wrong anyway. 11 out of 20.
Uh-oh.
What is the probability of randomly selected individual being someone that drinks chocolate milk regularly? Once again, is this conditional yet? No, it just wants to know what's the probability of them saying yes. Well, look at our graph here, our table. How many people said yes?
40.
40 total, right? So 40 over 100 can give us 40%. Any questions so far?
Nope.
Okay. What's the probability of randomly selecting a person that drinks chocolate milk? Drinks chocolate milk, given that they're a girl. So given they're a girl, so probability. Come on. The probability they said yes, given that they're a girl. So we need to find the probability of both over which one? Over which one? Anyone? So probability of both. So probability of yes and girl over the probability that what? The probability of A and B happening over, which did it say? Probability of A and B happening over the probability of the girl, right? Of the given. Well, what?
What?
You say you're confused?
No.
Do you have a question?
No, I wasn't talking to you at all. I was talking to my
Okay. So what's the probability that they said yes and are a girl? How many people said that?
Yes is total is 40.
Yes and a girl. 12.
James.
Over. How many girls are there? 45. So 12 over 45. Well, what can we reduce that to? 4 over 15. Approximately what percentage? It's a probability of both things happening or the probability of the given?
6.7.
26.7? Or 27%, we didn't tell you what to round to.
That's okay.
Okay. What's the probability of randomly selecting a boy given that the person does not drink the chocolate milk? Does not drink chocolate milk. Boy. Well, so it's a probability of a boy given they said no. So I want the probability of both happening. Did you not? What? What do you want? What do you need? I'm teaching. Yes.
Break.
It's 49%.
45%. 45.
So both over the given. Well, how many boys said no? 27. Over. How many people said no? 60. Right? Over the given. Probably over the given. So 27 over 60 reduces to 9 over 20, which is about what percentage? What?
This wording, sure.
45%.
Okay, well, I've been wrong for the past like 3 answers that I said.
This wording's like
Say it with your chest.
really screwing me up.
Why is it screwing you up, Q?
I don't know, 'cause, like.
The
I didn't
given
think-
part comes second. So given, they do not drink chocolate milk. That's the second piece.
So, given, like, you
Gi-
gotta read it in detail, like.
Like you gotta pay attention when you read it.
Okay.
Okay?
Should we pay attention regardless, right?
I mean, it's pretty.
One would hope, but. Alright, any questions so far?
No.
Okay. Let's keep going then. Ooh, you guys try. Alright.
On probability of. doing-
Try that table. Oh, these are the last 3 we got for today? That's easy. We have 3 problems left, that's it. Try that table first, we'll go through it and then we'll do the last problem.
When's this test?
This test is next Thursday.
Three review days, probably, right?
Started like shouting at each other, like Chicago shouting at Alex.
What'd you get for these? What'd you get for What'd you do for the numbers?
I remember the teacher was like, Lily.
So it's given that you're a boy.
Yeah.
God, you better leave.
It's like 14 plus 25.
It's not really
Going to the
shouting.
So,
Then they were like,
Because you have to ask.
they were like,
Because it's given that you're a boy.
no, they were like,
It's like all the boys. Well, what's the probability that you're a boy?
yeah. So probably out of all the boys, what's the probability they're going to picnic? Basically what we're looking for.
36%.
Because like,
Whoa.
So your given is basically your sample space. And you're trying to figure out the probability of which ones are actually going, or in other cases where it might not be going.
What?
So check your answers, please. Right? The probability they're going and that they're a boy, well, there's 14 boys that are going. Out of, there's 39 total boys, right? 14 plus 25. So 14 out of 39 should give us about 35.9% chance that it's a boy that is going. Find the probability that they're a girl given they're not going. Well, 5 girls are not going to the picnic, but there's 30 total people not going to the picnic. So probability that someone who's not going to the picnic is a girl would be 5 out of 30. Or 1 out of 6, which is 16.7%.
Screwed me up again.
That given part is your sample space. That's what you're working with. It's like boy. The total boys is my bottom number. That's my total people I'm looking at. People not going. That's my given. So that's a total people I'm looking at. There's 30 people not going. Then you got to figure out how many are girls. Goes on top. How many are going? 14. Okay? That kind of makes sense?
Yeah.
Are there any questions?
No.
Speak now, forever hold your peace.
Hold my peace.
Alright, let's do the last one together so we can get it done quickly. In a school of 1,200 students, 250 are seniors, 150 students take math, and 40 students are seniors who are also taking math. What is the probability that a randomly chosen student who is a senior, so that's our given, is taking math? Right, so probability of math given that they're a senior. Well, first we need to figure out the combined probability. How many of them are actually doing it? How many are seniors who are taking math? There are 40 students who are seniors and taking math. That goes on top. Over our given. How many of them are seniors?
250.
Hey, come on in.
I'm sure you guys miss it so much.
How many are seniors, Patrick?
250.
250 are seniors. That's my given. So that's the sample space I'm using out of 250. So that reduces to what? 4 over 25, which is approximately 16%. Does that make sense? Right? So we're looking, they're given their seniors. So that's our sample space, 250. 40 of them take math, so probability is 40 out of 250.
Done.
Okay? Done. Finito.